Hi friends, today I am giving a lecture on 15 puzzle problem in branch and bound in design and analysis of algorithms course. Okay, 15 puzzle problem was invented by Sam Lloyd in 1878. Okay, this problem was discovered in 1878 by the scientist named Sam Lloyd. Okay, next, the 15 puzzle problem consists of 15 numbered tiles on a square frame with a capacity of 16 tiles. Okay, so this is a square frame. On that square frame, 16 tiles capacity is there. We have to place 16 tiles. On that square frame, we have 15 tiles are placed that are numbered from 1 to 15 and one empty slot is there. So because of that reason, the capacity of the square frame is 16 tiles. On that 16 tiles capacity square frame, we have placed only 15 tiles that are numbered from 1 to 15. Okay, next one. The objective of this 15 puzzle problem is to transform the arrangement of tiles from initial arrangement to goal arrangement. Okay, this is the initial arrangement of tiles on 16 capacity frame. Okay, so our main objective is to transform this arrangement to this arrangement. This arrangement is called as initial arrangement and this arrangement is called as goal arrangement. Okay, next one. There is always an empty slot in the initial arrangement. Okay, in this initial arrangement, this is the empty slot. Okay, so this is called as initial arrangement and this is called as goal arrangement. In the initial arrangement, this slot is called as empty slot. Okay, next one is legal moves. So legal moves are the moves that tiles adjacent to empty tile either in up direction or down direction or left direction or right direction. Okay, so this is the empty slot. Okay, for this empty slot, what are the adjacent tiles? So 3 is the adjacent tile and 7 is the adjacent tile and 6 is the adjacent tile and 12 is the adjacent tile. Okay, so these tiles are moved based on the empty slot position either in the down direction, up direction, right direction and left direction. Okay, so legal moves are the moves in which the tiles adjacent to empty slot. This is the empty tile. Okay, the tiles adjacent to empty tile are 3, 7, 12, 6 are moved to either left direction. Okay, 7 tile can be moved to left direction. Now empty tile can be moved to this position. Okay, next one, 6 tile can be moved to this position. Empty tile can be moved to this position. The third tile can be moved to this position. Empty tile can be moved to this position. 12 tile can be moved to this position. The empty tile can be moved to this position. Okay, the tiles adjacent to empty tile are moved either in left direction, right direction, up direction and down direction. Okay, so these are the movements are there. The tile can be moved to either up direction or down direction or left direction or right direction. Okay, each move creates a new arrangement. Suppose the third tile can be moved to down direction. Okay, the empty tile can be moved to this position. Okay, now this is one new arrangement. Okay, next 7 can be moved to this position. Empty tile can be moved to this position. That is one new arrangement. 6 can be moved to this position. Empty tile can be moved to this position. This is also a new arrangement. Okay, that means each move creates a new arrangement. These arrangements are called as states of the puzzle. Okay, each move creates a new arrangement. Okay, each arrangement is called as a states of the puzzle. So according to that, how many number of arrangements are there? So this is one arrangement, this is one arrangement, this is one arrangement, this is one arrangement. Okay, 4 movements are there, 4 new arrangements are possible. So that new arrangements are called as the states of the puzzle. Okay, next one. The initial arrangement is called as initial state. This is one arrangement. This is called as initial arrangement. This initial arrangement is also called as a initial state. Okay, now our objective is to transform this initial arrangement to goal arrangement. Okay, this is goal arrangement. So this goal arrangement is also called as a goal state. This arrangement is also called as the initial state, and this arrangement is also called as a goal state. Okay, whatever the new arrangement we are obtained by moving the tiles that are adjacent to empty slide, one new arrangement is possible. That new arrangement is called as states of the puzzle. Okay, initial, this is initial state, and this is the goal state. Okay, next one, the state space tree for 15 puzzle problem is very large, because how many number of different arrangements are possible? 16 tiles are there, 16 factorial different arrangements are there. 16 factorial is equal to 20.9 into 10 power 12 different arrangements are possible. So that it is very difficult to draw the state space tree for the 15 puzzle problem. Only a portion of the state space tree shown in next slide. Okay, next one. In the state space tree, the nodes are numbered as per the level. Okay, in the first level, only initial arrangement is there. So that is node 1. Based on the empty slot, we have what are the possible moves are there. So then new arrangements are possible that are numbered or also. Okay, so each new arrangement can be denoted by one node. Okay, so in the state space tree, the nodes are numbered as per the level based on the movement of the empty slot. Any new arrangement comes, that new arrangement is also treated as one node. Okay, next one. Each next move is generated based on the empty slot positions. So based on the empty slot positions, okay, so next move is generated. Based on the next move is generated, a new arrangement is possible. Okay, that new arrangement is also denoted as one node. Okay, next one. Edges are labeled according to the direction in which empty slot moves. So based on the empty slot movement, so edges are denoted. Okay, so for example, this is the empty slot. Okay, suppose this empty slot can be moved to down. 12 can be placed in this position, and empty slot can be inserted in this position. So according to the direction, we have a edge. Empty slot moved from this position to this position. This is a downward direction. So the edge is labeled as down. Edge is labeled as down, and one new arrangement is occurred. Okay. Next one, 7 can be moved to this position. So left position. So an edge is labeled with left. One new arrangement is possible. Okay. 6 can be moved to right. Okay. So the edge is labeled with right. One new arrangement is possible. Next, 3 can be moved to down. Okay. The edge is labeled with the down direction. Okay, one new arrangement is occurred. That new arrangement can be treated as one node. Okay, now this is the sample state space tree. Okay, so this is the root node. Okay, so this root node becomes the E node while creating its children, 4 children. So E node is nothing but E node is a live node. That node is just created and its children are also generated. So that node is called as E node. Okay, now the root node becomes the E node. So this is the root node. This root node is the E node because its children are already generated. Okay, next we can decide which node to become an E node based on the estimation formula. Okay, among the 4 nodes, okay, which node becomes the E node, that can be calculated by using this formula. C cap of x is equal to f of x plus g cap of x. Okay, so by using this formula, we can decide which node becomes the E node. Okay, so this is the root node. So in the level 1, only root node is there. It can be denoted. It can be denoted by state 1. Okay, state 1. Next, in the level 2, there are 4 nodes are there. This is node 2, node 3, node 4, node 5. In the level 1, 4 nodes are there. Okay, in the level 1, only a single node is there. So this is a state 1. Okay, next in the second level, there are 4 nodes are there. So this is node 2, node 3, node 4, node 5. In the next level, whatever the nodes that we are created, that are 6, 7, 8, 9, 10. Okay, so these are the states of the puzzle. This is the first state, second state, third state, fourth state, fifth state. Okay, so each and every state can be represented by a node number. Okay, next one. C cap of x is equal to f of x plus g cap of x. Before going to this formula, how we are calculating the cost? First, what are the next nodes? How we are created? Okay, so this is the root node. This node becomes the E node. Next, what are the possible arrangements are there? So now, first one, node 3 can be moved to down. Node 3 can tile 3 can be moved to down. So then this empty tile can be moved to this position. Okay, we are creating one arrangement. That arrangement is called as new arrangement. So that is 1, 2. This empty tile can move to this position. So this position is vacant position. Okay, so now this empty tile can be moved to this position. Next, 4 is no change, and 5 and 6, this is 8. Next, 9, 10, 11, 12, 13, 14, 15, 7. Okay, so now no empty tile can be moved to this position, and this position 3 becomes down. Okay, so tile 3 can be moved to down position, and empty tail can be moved to up position. Okay, so now this is called as empty tail can be moved to up position. So empty tail can be moved to up position. Okay, next one. Next one is the empty tail can be moved to right position. Okay, so empty tail can be moved to right position. 8 moved to this position. Empty tail moved to this position. So empty tail moved to right. Here empty tail moved to up position. Here the empty tail moved to right position. So then we becomes 1, 2, 3. There is no change. And 5, 6. Empty tail can be moved to this position. 8th tail can be moved to this position. Empty tail is this one. 9, 10, 11, 12, 13, 14, 15, 7. Okay. Next one. The empty tail can be moved to down direction. Okay. This tail, empty tail can be moved to down direction. 11 can be moved to up direction. So that is, this is down direction. Okay. So now 1, 2, 3, 4, 5, 6. Empty tail can be moved to this position. 11th tail can be moved to up direction. 8. So 9, 10. Empty tail. 12. 13, 14, 15, 7. Okay. Next one. Empty tail can be moved to left direction. So now it is moved to left direction. So then 6 can be moved to this position. Okay. So now 1, 2, this is the left direction. 1, 2, 3, 4. So 5. This is empty slot. 6, 8. 9, 10, 11, 12, 13, 14, 15, 7. Okay. So based on the movement of the empty slot, okay, the new arrangements are possible. Okay. On the edges, okay, on the edges what we are write? Okay, the empty slot can be moved to either up direction or right direction or down direction or left direction. Suppose empty slot can be moved to up direction. One new arrangement we are getting. That new arrangement can be treated as one node. That node is numbered as 2. Okay. The empty slot can be moved to right direction. Okay, one new arrangement we are getting. Okay, that node number can be treated as 3. The empty slot can be moved to down direction. So then we are getting a new arrangement. The empty slot can be moved to left direction. Then we are getting a new arrangement. Next one. Next we are taking this new arrangement. Again, empty slot. What are the possibilities of movement of empty slot? That slots can be denoted in this way. So in this way we are getting the state space tree from in various levels. Finally, where we are stopped? Okay, finally at which node level, at which node in a particular level, then we are reaching the goal state. Goal state is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the last is the empty slot. That is the goal arrangement. If we are reaching the goal arrangement, we have to stop the extending of this procedure. So then the construction of state space tree is completed. Okay. Next one. So here, see how we are calculating the cost. C cap of x is equal to f of x plus g cap of x. Suppose we are taking, this is the node x. Root node can be treated as x. Now we are calculating the C cap of x. C cap of x is equal to C cap of x is equal to, so this is a node x. C cap of x is equal to f of x plus g cap of x. F of x means length of the path from the root node to node x. So node x is the root node. So length of the path from root node to root node is 0 plus g of x is the number of non-blank tiles which are not in their goal position for node x. Okay, that means, okay, tile 1 is there in the correct position when we are comparing to the goal position. Yes. Tile 2, yes, it is in correct position. Tile 3, it is in correct position. Comparing this root node with the goal node. Okay, so 4, it is already there in the correct position. 5, it is already there in the correct position. 6, it is already there in the correct position. Okay, 7th, it is not there in the goal position. Okay, so that is one wrong. Okay, number of non-blank tiles which are not in the goal position. First one, 8, it is correct position. 9 correct position, 10 correct position, 11 correct position, 12 correct position, 13 correct position, 14 correct position, 15 correct position, 7 it is not in the correct position. That is 1 plus 1. So among them we have subtract minus 1. Okay, because empty tile cannot be counted. So 2 minus 1, that is 1. That is equal to 0 plus 1 is 1. Okay. How many number of wrong tiles in their positions? Okay. Node 1, tile 1, it is in the correct position. Tile 2, correct position. Tile 3, correct position. Tile 4, correct position. Tile 5, correct position. Tile 6, correct position. Tile 7, okay, it is not there. So that is one wrong position. 8 correct position, tile 9 correct position, 10, 11, 12 correct position, 13, 14, 15 correct position. But 7, it is not in the correct position. So this is one wrong position, this is one wrong tile position. 1 plus 1, subtract minus 1 because empty tile cannot be counted. So 2 minus 1, that is 1. This is the g cap of x. Therefore, c cap of x is equal to 0 plus 1, that is equal to 1. Now, for this node, how we are calculated? Now, suppose this is node x. We have to take, this is the node x. So, that is equal to f of x. F of x means length of the path from the root node to the node x. Okay. So, this is the root node and this is the node x. What is the length? So, length means that is 1. Okay. So, this is level 2, this is level 1. 2 minus 1, that is 1. Length of the path from root node to node x is the length from this level to this level. That is 1. 1 plus, next, what are the non-blank positions are not there in their correct position? Okay. So 1 correct position, 2 correct position, 3 correct not 3 correct position, not in correct position, 4 it is correct position, 5th correct position, 6th correct position, 3 it is not in correct position, 8 already correct position, 9, 10, 11, 12 already in correct position, 13, 14, 15 already in correct position, 7 it is not in correct position. So 3 minus 1, that is 2. So that is 1 plus 2, that is equal to 3. Okay. Next one, C cap of now node x is this one. So length means length from root node to this node is 1. Level 2 minus level 1, that is 1. How many tiles not there in correct position when we are comparing to the goal positions? Okay. 1, 2, 3, 4, they are in correct position. 5, 6 correct position. 7 not correct position. 8 not correct position. That is 1 plus 1. 9, 10, 11, 12 correct position. 13, 14, 15 correct position. 7 not correct position. So 3 minus 1, that is 2, that is equal to 3. Next one, this one, suppose we are taking, this can be taken as node x. So C cap of x is equal to length from root node to this node is level 2 minus level 1. 2 minus 1, that is 1, plus how many tiles are not there in correct position when we are comparing to the goal position. Okay, 1, 2, 3, 4 correct positions, 5, 6 correct position, 11. Here it is a 7, but it is 11. So 1 not correct position, 8 correct position, 9, 10 correct position. This is not the correct position. 12 correct position, 13, 14, 15 correct position. 7 is not in correct position. So that is 3 minus 1, that is 2, that is equal to 3. Next one, now suppose this can be called as node x is equal to f of x. F of x means length from root node to this node is 1. How many number of edges are there? Only one edge is there. Okay, 1 plus how many number of tiles not there in correct position when we are comparing to the goal position? 1 or 1, 2, 3, 4 already in their correct positions. 5 already correct position. 6 it is not there in the correct position. 7 it is not there in correct position. 8 it is already correct position. 9, 10, 11, 12 correct positions. 13, 14, 15 correct position, and 7 not correct position, minus 1. So that is 1 plus 2, that is equal to 3. So in this way we have to extend the state space tree until we are reaching the goal position. Okay, so up to this point we have to calculate the cost. In the next level, so what is the f of x value? Length from root node to next node in the level x. So that is how many number of edges are there? 2 edges are there. Level 3, level 1. 3 minus 1, that is f of x is equal to 2. Okay. G of x can be calculated that how many number of tiles are not there in correct position when we are comparing with the goal position. Okay. Now this is the initial assignment. And final node 23 is the goal assignment. Okay, this is initial assignment, this is the goal assignment. Okay, so initial assignment can be denoted by node 1, this is the root node, and this is the e node, and its childrens are node 2, node 3, node 4, node 5, and node 2 childrens are node 6, node 7. Node 3 children are node 8, node 9. Node 4 children are node 10, node 11, node 12. Node 5 children are node 13, node 14, node 15. Okay. Node 6 children are node 16. Node 7 children are 17 and 18. Node 8 children are 19. Node 9 children are 20, 21. And node 10 children are 22, 23. When we are reaching the goal assignment, we are stopping the extension of the procedure. This is the goal assignment. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So once we are getting the goal assignment, we have to stop the extension of the nodes. Okay, next one. So based on the movement of the empty slot, this empty slot can be moved to right direction, left direction, up direction, down direction. So this is empty slot can be moved to up direction, right direction, down direction, left direction. Okay. So the empty slot can be moved to up direction, 3 can be moved to this place, and empty slot can be moved to this place. Okay. Remaining all are same. Next, the empty slot can be moved to right direction, this right direction. 8 can be moved to this place, empty tile can be moved to this place. Then we are getting node 3. Next one, empty slot can be moved to down direction. So empty slot can be moved to this position, 7 can be moved to this position. The remaining all are same. Next, the empty slot can be moved to left direction. So then 6 comes to this place, empty tile can be moved to this place. We are getting, so node 2, node 3, node 4, node 5. Next one, we are considering node 2. What are the empty slots movements? Empty slot move, there is no movement to up direction. Okay, there is no movement to right direction. There is no movement to left direction. Down direction, if you are down direction, we are getting the same. Okay, so because of that reason, only right and left are possible. Next, what are the movements for empty slot? Only up and down. What are the movements are possible? Right, down, left. What are the movements are possible? Up, down, left. Now going this one, what are the possible moves are there? Only down move. By considering this one, what are the possible movements down and left for the empty slot? What are the possible movements? Only left movement for empty slot. What are the possible movements? Only down and left. Next, this one, what are the possible movements? Up and down. Once we are getting the we have to stop the extending procedure. In the previous slide also, we are calculating the cost. Same procedure can be applied to this one. Okay, thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasarao. This is only a part of the state space tree for 15 puzzle. Next here, edges are labeled according to the direction in which empty tile moves. Based on the empty tile move, what are the directions are possible? Based on the directions, we are writing the edges. On the edges, what direction we have to move empty tile? That can be shown. Okay, so thank you. Hi friends. Today I am giving a lecture on 15 puzzle problem using least cost branch and bound in design and analysis of algorithms. In the previous video, we are already discussed about what is 15 puzzle problem, how we are solving the 15 puzzle problem that we are discussed in the previous video. Now in this video, how 15 puzzle problem can be solved using least cost branch and bound. Okay, so this is a 16 capacity square frame. On that 16 capacity square frame, we have to place 15 tiles that are numbered from 1 to 15, but one tile is empty tile. Okay, this empty tile can be moved either in left direction or right direction or up direction or down direction. Okay, so there are 4 directions are there. The empty tile can be moved. Okay, so the right direction, the left direction, up direction, right direction. Okay, so based on that, so this is up direction, this is a right direction, this is a down direction, and this is a left direction. Okay, suppose this empty tile can be moved up, so 3 becomes down and empty tile can be moved up. Okay, so this is the outcome of by moving empty tile from upwards, one step upwards. This is the outcome we are getting. Okay, this empty tile can be moved to up and 3 can be moved to down. So this is the outcome we are getting. The remaining tiles cannot be changed. Okay, next. So this empty tile can be moved to right. Okay, so this empty tile can be moved to right. 8 can be moved to left. Okay, so 8 can be moved to left. Empty tile can be moved to right. So this is the outcome we are getting. Okay, next one. This empty tile can be moved to down. Okay, so this empty tile can be moved down. After that, the 7th tile can be moved to up. So this is the outcome we are getting. Okay, next one. The empty tile can be moved to left. So this empty tile can be moved to left. sixth tile can be moved to right. So this is the outcome we are getting. Okay, next one. So now consider this node. So this is node 1. Initial arrangement is node 1. So after moving the empty tile to upward direction one step, we are getting node 2. Moving empty tile one step to the right, we are getting this node 3. So down node 4 we are getting, left node 5 we are getting. Okay, next one. Now consider node 2. Okay, so this empty tile can be moved to left direction or right direction. There is no possibility of moving up direction. Okay, suppose this empty tile can be moved to down direction, we are getting the same, so that the down move cannot be used, only left and right moves can be used. Okay, this empty tile can be moved to either left direction or right direction, but there is no possibility of moving up direction. Suppose it can be moved to down direction, so the same node 1 we are getting. So because of that reason, the down move cannot be used. Okay, so next one. Suppose, so we have to take the right move. Okay, the empty tile can be moved to right direction. So 4 can be moved to this place and empty tile can be moved to this place. So this is the outcome we are getting. So this is node 6 because node 5 is ended in level 1. This is level 1 and this is level 2. Level 1 contains only node 1. Level 2 contains node 2, node 3, node 4, node 5. After that, in level 3, this is the first node, that is node 6. Okay, next one. The empty tile can be moved to left direction. Okay, the empty tile can be moved to left direction. The tile 2 can be moved to this position. Empty tile can be moved to this position. So this is the outcome. This is the node 7. Okay, next one. Now consider this one, node 3. Okay, so here the empty tile can be moved to up direction. Empty tile can be moved to left direction. Empty tile can be moved to left direction. Same we are getting, so that left direction cannot be used. Empty tile can be moved to up direction. Empty tile can be moved to down direction. Empty tile cannot be moved to right direction because there is no tile is there at the right hand side. Okay, so it is ended. Okay, so only up direction and down direction we have to use. So empty tile can be moved to left direction. So this is the node 1 we are getting. So because of that reason, so left move cannot be used. Okay, up direction. So empty tile can be moved to up direction. 4 can be moved to this place. Empty tile can be moved to this place. So this is the outcome we are getting. This is node 8. Okay, next one. Empty tile can be moved to down direction. So this empty tile can be moved to 11th position. 11th tile can be moved to empty tile position. So this is the outcome we are getting. So this is node 9. Okay, next one. So now consider node 4. Okay, so the empty tile can be moved to up direction. Okay, so node 1 we are getting, so that up direction move cannot be used at this place. The empty tile can be moved to left direction. The empty tile can be moved to right direction. The empty tile can be moved to down direction. Okay, so the empty tile can be moved to right direction. 11th tile can be moved to this place and empty tile can be moved to this place. So node 10 we are getting. Okay, next one. The empty tile can be moved to down direction. 15th tile can be moved to this position. Empty tile can be moved to this position. So this is the outcome we are getting. This is node 11. Okay, next one. The empty tile can be moved to left direction. 10th tile can be moved to this place and empty tile can be moved to this place. So then So node 12 we are getting. Okay, next one. Now consider node 5. Okay, so node 5, so the empty tile can be moved to right, then we are getting the node 1. So that right movement cannot be used here. Okay, so the empty tile can be moved to left direction, up direction and down direction. Okay, suppose the empty tile can be moved to left direction, so tile 2 can be moved to down and empty tile can be moved to up. So this is node 13 we are getting. Okay, next empty tile can be moved to down, 10th tile can be moved to this place and empty tile can be moved to this place. So this is node 14 we are getting. Next, empty tile can be moved to left position, 5th tile can be moved to this place, empty tile can be moved to this place. So this is the remaining tiles cannot be changed. So node 5, the outcome is the node 15. Okay, next one. Now consider node 6. Okay, consider node 6. So this is the empty tile. Empty tile cannot be moved to right direction because so that this is a 16 capacity square frame ended at this position. So because of that reason, the empty tile cannot be moved to right direction. Next, the empty tile can be moved to left direction. We are getting node 2. Okay, the empty tile can be moved to only, cannot be moved to up direction. Okay, because the 16 capacity square frame ended. Okay, there is no up direction. So because of this reason, only one move is available. That is, so the empty tile can be moved to down direction only. So this move only exists. The remaining moves cannot be possible. Okay, so one direction is possible. That is left direction. That is right direction. If we move to right direction, if we move to right direction, we are getting node 2. Okay, so only down direction is possible. So the empty tile can be moved to down direction. 8th tile can be moved to this place. Empty tile can be moved to this place. So this is node 16 we are getting. Okay, now consider node 7. Okay, so the empty tile can be moved to left. We are getting node 2. The empty tile can be moved to right. Then we are getting node 2. So that right move cannot be used here. The empty tile can be left direction. Yes, it is possible. The empty tile can be down direction. It is possible. The empty tile cannot be moved to up direction because the 16 capacity square frame ends with this position. So because of that reason, up direction cannot be possible. Only down and left are possible. If we go for right, the node 2 we are getting. Because of that reason, right movement cannot be used. Okay, so down direction, this tile can be moved to down. Okay, so 6th tile can be moved to up. We are getting node 7. Okay, next left direction, this tile can be moved to left. Node 1 can be moved to this place. So this is the outcome we are getting, that is node 18. Okay, next, now consider node 8. Okay, so here what are the possible movements are there? Up direction, it is not possible. Right direction, it is not possible. Only left direction, it is possible. Down direction, we are getting node 3 same. Okay, only left move is only possible. Okay, so it can be moved to left. Tile 3 can be moved to this place. Empty tile can be moved to this place. We are getting node 19. Okay, next one. Go to node 9. Okay, node 9. Here right direction is not possible. Left direction, yes, it is possible. Down direction, yes, it is possible. Up direction, we are getting the same node 3. Okay, So only two moves are possible, down movement, down and left. Okay, first, so we can take down. So this empty tile can be moved to down. 12th tile can be moved to this position. Empty tile can be moved to this position. Then we are getting node 20. Okay. Next one, left direction. The empty tile can be moved to this place. Tile 7 can be moved to this place. This is the outcome we are getting. That can be treated as node 21. Okay. Now consider node 10. Okay. So node, this is the empty tile. Empty tile can be moved to left direction. We are getting the same node, that is node 4. So left movement cannot be used. Okay. Empty tile can be moved to up, as it is possible. We can take the up movement. Empty tile can be moved to down, as it is possible. This is down movement. Empty tile cannot be moved to right direction. Okay. So then only up and down movements are used. If we go to right, there is no possible. If we go to left, we are getting node 4. So then up movement we are consider. By considering the up movement, so empty tile can be moved to this position and 8th tile can be moved to this position. So this is the outcome. It can be treated as node 22. Okay. Next, down movement. The empty tile can be moved to this place. 12th tile can be moved to this place. This is the outcome. So this is the goal arrangement. Okay. Goal arrangement means empty tile is there at the end position. Okay. So this is the end position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So this is our goal arrangement. Okay. This is the initial arrangement. Our main objective is to transform the initial arrangement to goal arrangement. At node 23, we are getting the goal arrangement. So further, there is no extension of these node 12, node 13, node 14, node 15. Okay. Only our goal is we are getting the goal arrangement for the initial arrangement. Once we are getting the goal arrangement, we have to stop the extension of the procedure because our objective is reached. Okay. Now, cost function how we are calculated. C cap of x is equal to f of x plus g cap of x. F of x means length of the path from root node to x node. For example, so node 23 is the goal arrangement. Okay, so this is node x, this is the root node, node 1 is the root node. Okay, what is the length of the path from root node to this node? So this is the level 1 and this is the level 2 and this is the level 3 and this is the level 4. Okay, so this is level 4. So level 4, so 1 edge, second edge and third edge. 4 minus 1, that is 3. So length of the path from root node to node x is how many number of edges between them from root node to goal node, that is node x. This is 1 edge, this is second edge, this is third edge. So length of the path is 3. Okay. Next, g cap of x is equal to number of non-blank tiles which are not in their goal position for node x. Okay. So these are the tiles, non-blank tiles. These are the non-blank tiles except this tile. Okay. How many number of tiles cannot be there in their goal position? Okay. So all tiles are there in their goal position. So because of that reason, g cap of x is equal to 0 for this node. Okay. So therefore, c cap of 23 is equal to length of the path from root node to node x. This is the node x. Length of the path from root node to node x is nothing but number of edges between them. This is the first edge. This is the second edge. This is the third edge. So therefore, f of x is equal to 3 plus how many number of tiles that are not there in their goal position. all tiles are there in their goal position. So then g cap of x is equal to 0. So 3 plus 0, that is equal to 3. So this is the cost of that node x. This is the lower bound value. Lower bound value on node x is equal to 3. Okay. So this is the formula. C cap of x is equal to f of x plus g cap of x. Okay. Now, how we are calculating these costs? Okay. So C cap of 1, C cap of 2 up to C cap of 23. Okay. First one, C cap of 1. Okay. So C cap of 1 is equal to f of x. So this is the node x, length of the path from root node to node x. So this is node x. Okay. So length of the path. What is the length of the path from root node to node x? So root node is same, node x is same. So that is 0. Plus how many number of tiles that are not there in their goal position? 1, it is there in their goal position. 2, it is already there. 3, it is already there in their goal position. 4, it is already there. 5, it is already there. 6, it is already there. 7th tile cannot be there in their position. That is the wrong position. 8th already correct position. 9th already correct position. 10th already correct position. 7th, here this tile cannot be there in their correct goal position. So that is 2 wrong positions. 11, this is also wrong position. 3, 13, 14, 15. So this is not considered because one empty tile is there. Okay. Or if it can be considered, subtract minus 1. Okay. Total 4 minus 1, that is 3. So that is equal to 0 plus 3 is equal to 0 plus 3 is equal to 3. Okay. So next one. For node 2, how we are calculated? So the length of the path from root node to node x. This is node x. Length of the path from root node to node x is 1. 1 plus how many number of tiles that are not in their goal position? Okay. 1 already correct position. 2 correct position. 3 it is not there. 4 okay. 5 okay. 6 okay. It is not correct position. 2 8 correct position, 9 correct position, 10 correct position, 7 it is not correct position, 11 it is not correct position. So 4, this is not correct position, this is correct position, this is correct position, this is correct position, this is not correct position. 5 minus 1, that is 4. So 1 plus 4, that is equal to 5. Okay. So in this way we have to calculate all the lower bound values. Okay, now consider this node 6. Okay, how we are getting node 6? Okay, so this is node x, length of the root from this node to this node. Okay, so one edge and second edge. So that is f of x is equal to 2. How many number of edges from root node to this node? That is 2. Plus how many number of wrong tiles positions compared to the goal position? Okay. 1, 2. This is wrong position. This is wrong position. This is wrong positions. Up to now, 3 wrong positions. 4th wrong position. 5th wrong position. 6th wrong position. 6 wrong positions are there. So 6 minus 1, that is 5. 2 plus 5, that is equal to 7. Okay. In this way, we have to do that one. Next, this level we have to solve one example for node 16. So for node 16, so that is, what is the length of, this is node x, length of the path from root node to this node? So that is first edge, second edge, third edge. So node 16, this is 3 plus how many number of wrong positions? That when we are compared to goal position. Okay, how many number of tiles that are in wrong position when compared to the goal position? 1, 2 already correct, 3 it is not there, and 8 it is not there, 2 wrong positions. 5, 6, these are 2 wrong positions, so 4 wrong positions. 9, 10, this is wrong position, this is wrong position. 6 wrong positions. 13 okay, 14 okay, 15 okay, 12, this is 7th wrong position. Okay, So 7 minus 1, that is a 6. 3 plus 6 is equal to 9. So in this way, we have to find out the lower bound for a node. Okay, lower bound for a node. Next, so least cost branch and bound where we are applied. Okay, so now this cost is equal to 3. Okay, next, what is this cost? Node 2 cost is 5. Node 3 cost is also 5. Node 4 cost is 3. Node 5 cost is 5. Okay. Okay. Node 1 cost is 3. Node 2 cost is 5. Node 3 cost is 5. Node 4 cost is 3. Node 5 cost is 5. So 5, 3, 5, 5. Among all the 4 nodes, node 4 has the least cost. This node is considered. The remaining nodes are killed. The remaining nodes are killed. So this is nothing but bounding. Bounding is nothing but we have to kill the nodes except the minimum cost node. This is nothing but branching. Okay. Now, so node 4 can be extended. We are getting node 10, node 11, node 12. Node 10 cost is 3. So that is a C cap of 10 is equal to 3. Node 11 cost is also 5. Node 12 cost is also 5. 3, 5, 5. Among the 3 nodes, node 10 has the minimum cost. So node 11 is killed, node 12 is killed. Okay. So now, so for node 10 there are 2 children, node 22, node 23. So node 22 cost is 5, node 23 cost is 3. So among the 2 node, which node has the minimum cost? Node 23 has the minimum cost. Now node 23 is the active node. So this node is killed. Node 22 is killed. So node 23 is the goal arrangement. So this is the goal arrangement. So now we stop the extension of this procedure. Okay, because we are getting the goal arrangement. So C cap of 23 is equal to 3. So this is the state space tree for 15 puzzle problem using least cost branch and bound. So thank you.